Hello and welcome to the Advent of Code 2021, day 13. Today we are giving a description of a matrix where some dots are marked, and then we have a list of folding along x and y axes so that this matrix is essentially folded. So the dot that turns out to be essentially, you have to imagine that this matrix is printed on a sheet of transparent paper, and every dot is a sort of mark of ink on this paper. And when you fold it along this axis, so for example in here you have an horizontal folding, or here you have a vertical one. Every time you fold, you end up having a new matrix which has the half of the size of the previous one. And whenever there was a dot in one of the two sides, of course one side is mirrored because it's folded, you get a dot in the folded version. So essentially you can imagine that you have an OR of the dots. Now let's see, this problem is still not as complex to make me think that I have absolutely to do single steps, but let's see how I approach a problem that can be a bit complicated. So first of all, I use the input example. So instead of copying the puzzle input that the website gives me, I copied the sample input. So this one that is in the description of the problem, so that I can try my code already on that and see that it works. And let's see how I do it step by step. So I already created a scaffolding, copying from exercise 12. Here I have in day 13 the code that the website gives me. I am going to check also whether the input that the website gives me has multiple folding. Yes, a few. Okay, that's expected. Fine. So the request is to basically calculate the folded version of the algorithm and count how many dots are visible after completing only the first fold instruction. So in our case, only this, fold along y equals 7. So let's start by representing this data. So one thing to notice is that here if you look at the problem, you immediately think about a matrix because this is a grid. And it's possible to create a list of lists, but I think it's a bit verbose and ugly to read because every time you have to iterate over the points, you have to do a for cycle with another for cycle inside. Much better is to notice that the information that we have here is just a list of coordinates. And what we care about is always to check whether a coordinate is in one of the two sides, so the original and the mirrored one. Doesn't matter if it's vertical or horizontal. So essentially what we have is a set of points. And I personally prefer much this representation because it's just easier to handle. You have a set, and every time you have a set of coordinates, you can easily iterate over them, do an union or a disjoint or whatever. You can do a lot of stuff, and that's very easy to represent. So I iterate over the lines. So for line in fr, what do? I have to check whether this line has coordinates or is a folding instruction. How do I check? I check that there is a comma. So if there is a comma in line, then we are parsing a coordinate, because fold along y or x equals something doesn't have any comma symbol inside. So I create a set of coordinates. It's an empty set, and now I parse it. So x nothing, y is equal to line dot strip, because I want to ignore the new line, dot partition by a comma. So essentially I'm removing the new line character from a line, splitting it by comma because I know that there is one and only one comma in that line, and I have two values which are the x and y coordinate. And and now I add to the set what, not directly x and y because they are strings now, but the string x the integer x and the integer y. Okay, if we have a coordinate. Then we have a list of folding instructions, and again I say that if an equal sign is in line, similar thing, I have, instead of coordinates, now I have folding instructions, is a list. This time is a list because there is an order, so I don't care about the order of these coordinates, I just care about the fact that they are or not in the set. But for folding there is an order, and it's important, so I keep folding instructions like that. What I do, I split again, so I say what is it? We have something like fold along blah blah. So this is an example of what I have in the code. Fold along y equals 7. I want to get the direction, so I what I do, I can simply I will split by the equal sign. So I do line.split by equal sign. This will split this part for fold along y, and this part, the number. So parts, let's call it parts, doesn't matter what it is. Now we have parts, which is essentially a list of two values. In fact, we could also have used the, let's say description, nothing, and value. Let's say axis. So line, I also here I have to strip the line. So now I just used the same partition, not split instruction used here. So I split the line into parts before and after the equal, and now I can simply say, okay, from description, which is desk, so this part here before the equal, I want to get the last component, and from axis, which is a number, I just want to keep it. So I say folding instruction dot append what? I want to append a tuple where the first element is the direction, so x or y. What is the direction is the last character of the description. So I simply say description -1, which means get me the last character. And then I have the value, this 7, which is int of axis. Sorry, I call it axis here. It was actually amount. So not the axis, but the amount. Or better, is the position. So position is the position of the line across it which I fold. Okay, that's it. So I have folding instructions, and now we can start implementing the folding. One thing to notice is that it's very hard to debug this just by looking at the numbers. It's much better if I can reconstruct this matrix of sort. So let's do it. Let's create a function that visualizes the matrix. This is only for us humans. This will not be part of the problem because we actually do not have to visualize it to get a solution. But we humans want to see it. And this is essential to actually get an idea of what we are going to represent. So when we visualize, we have what? A list of coordinates. And we're going to print this matrix. So I first need to know how big is the matrix, and we do not know at all whether this is going to be okay. An interesting thing to notice is that nowhere here we have the complete size of the matrix. So is there a description here of how big it is? No. Okay, very interesting. So we never know exactly how okay, so there is no information about the complete size of the matrix. That's very interesting. We know the coordinates but not the size, so we can only assume if I read correctly, that the matrix is as big as the complete size of the other thing, which is fine. So basically we have to find how many rows and columns are there. So I go through the coordinates and I simply get the maximum. So x max, let's call it row and columns, so it's easier to imagine it. So how many rows are there? We know from the problem description that the first element is the x, and the second is the y, and it decreases downward. So this is not like a Cartesian plane. This is more like what computers do to represent graphics on the screen. So the x-axis goes from left to right, but the y-axis goes top down. It increases as you go down, so it's reversed. The y-axis is reversed compared to the Cartesian plane we know and love. Okay, so x max is what is the maximum of, let's call it x, because that's what it is, for xy in chords. So here we are simply iterating over all the coordinates that are in chords, x and y, and getting the maximum one. This we can just ignore because we don't care about x, epsilon in this, y in this case, and then we do the same for y. Of course, we have y. We do not want x, but y, and that's it. So we just got maximum x and y. Now what we do? We have to print row by row. Notice that the rows are y, so we have to iterate over y. For y in what is it? In the range that goes from 0 to y max, we iterate over x that goes from, for x in range from 0 to x max. And now we have two coordinates, and we want to know whether we have to print a dot or an hash sign, so the octotorpe. So if xy in chords, it means we have this coordinate, so we print a sharp sign. Otherwise, we print a dot. This is still not good because the print will go to the new line, but we want to go to the new line only after printing our row. So instead, we can transform this thing into a list. So we can say row is a list, or better, row is a string, easier. Here, instead of printing, we add the symbol to the row, so we do not go to the new line automatically. And then after the 4, we print the row. So we can immediately check whether this part will be printed correctly. So visualize chords. Let's run this thing. Okay, so this is what we just printed. This should be identical to this thing. So 3 dots, sharp, 2 dots, sharp, 2 dots, sharp, seems correct. And at the bottom we have sharp, dot, sharp, blah blah blah. This is not correct, we miss it. What are we missing? We're missing the last line. Why? Of course, we are missing it because this is ranging over y max, not y max plus 1, because that's the maximum coordinate, not the length. And let's check if we did the same mistake for the x coordinate. Yes, we did. Again, this is x max plus 1, because I'm not iterating over the length of an array, I'm iterating over the value, so I know that the max value is actually inside. So you see that we spotted this error, this by 1 error, which is extremely common in this kind of problem, just by visualizing. That's nice, because now we can easily implement the rest and see the results directly in our screen. Okay, so we are asked by the problem to calculate the folding. So let's implement also the folding. So we implement two functions, fold x and fold y. And the problem is here. What is it doing? This is a fold y. So let's start by fold y. So we can immediately see the solution. Fold y, we receive coordinates, again, and how much to fold. So let's say if y val. Okay, ugly name, but I cannot think about anything better. So how do we fold? We simply have to decide. We simply create a new set of coordinates that we call chords ret to say return chords, or let's call it ret and that's it, which is a set, so the new set we're going to create. And then we iterate over all the coordinates. So for x, y in chords, what we want to do first, we want to check whether a point, so for example this one, has to be moved by the folding or not. And the condition is easy, because if y is lower than y val, which means that we are above the folding line, we don't do anything. We just copy it to the return value. So ret dot add xy. Nothing fancy here. Otherwise, what we have to do here is a bit more interesting, because we have to fold this dot. So we have to find the coordinate of a dot, for example this one, where will it go once I fold. What is this value? That's very interesting. This should be the folding line, sorry, the coordinate y of this value minus the folding line. So for example here we have 7, this will be 10, and it will go here at position 3. No, sorry, we'll go at 7 minus 3. So essentially the difference between the folding line and the value is reversed and goes above the folding line. But this is maybe a bit confusing, but since we have a visualization, it's easy to just try and see what happens. So ret.add, the coordinate x stays the same, the coordinate y becomes y minus y val, so that's the distance between the folding line and the coordinate itself, and this becomes y val. This is subtracted by y val, so the lower it is from y val, the higher will be compared always to y val. This can be simplified a bit, can become 2 multiplied by y val minus y, but I just keep it. And then I have to return. What? I return the ret value. Can we directly try this function? Yes, of course we can. That's why we wrote it. We have the visualization, and we can just simulate this part, this step. So I try to, after printing this in the visualization, I call it chords2 equal fold y of chords, and what was the value? It was 7, I think. Yes, 7. And then I visualize. I print a nice separator, so I can easily say something like this. And then I visualize chords2. Easy peasy, hopefully. So let's see what happens now. Okay, there is an error. I gave 2 arguments to set.add. The error is here, yes, because I didn't put the parentheses. So it's not creating a tuple, but calling it as is. Again, same error. Of course, I didn't also in the first step. I just missed it. Okay, missed it. Oh, I hate English pronunciation. Okay, so this is our separator. The first part is correct, we already knew. Let's check that this is identical. We have 3 hashes at the bottom right. We have 1 hash here, 2 hashes here. 1, 1, yes, this seems correct. It's interesting that there is a small difference, which is what happens when we have these two lines that are empty. At the moment, I don't think that's important, but I wonder what happens if we have multiple folds, because if we fold, this should never be important, because if we fold on this axis, it doesn't matter how many empty lines we have here. They just get, we don't need the empty lines to calculate the coordinates. If we fold on the right, that's the same. I'm not totally sure this is actually effective, so let's just assume it's not. If I fold like this, I also don't care about this part. Yeah, I think the transparent parts is we do not need to keep track of the empty lines. So my visualization is a bit different because I do not have these empty lines here. I stop immediately when I do not have dots at all, but this should be fine. So let's go forward. What is the okay, so the problem is asking also to implement the left fold, which is this one. What is, I don't see it anymore. Where is it? Okay, fold along x5. Implementing this fold is simple. I simply copy fold y and change the coordinates. So fold, I call it fold x, xval, and same thing goes here. So nothing strange. Is exactly the same formula. I just swap x and y. What is the problem asking us to do is now to fold it on the x-axis. So fold along x. So I again do the same. Fold chord 3 equals fold x of chords 2, because we are folding what was already folded, and we print chords 3. And maybe I also put some extra new lines here, because otherwise that gets very confusing. Okay, let's run it and see what happens. Okay, nice. We got a square here, which is what the problem expected. Okay, good. So this seems to be working. And then what's asking us to do is to count how many dots are there after completing the first fold instruction. So solution 1, so part 1, we get what, the coordinates and the folding instructions. So let's invoke it. So here I invoke the part 1 with coordinates and folding instruction. What does part 1 do? It will receive the coordinates and folding instructions, and we'll run the first folding instruction. So if folding instructions 0 is equal to x, yes, so if it's equal to x, then we return what? The length, so the amount of dots that are in fold x of chords and folding instruction 1. So we just fold, and what we get is a set of coordinates. We care only about the number, so we just count them. Otherwise, we are folding on the x-axis, so we fold, sorry, on the y-axis, and that's exactly it. Let's run it. Oh, there is an error. That's incredible. Impossible. Okay. So y lower than y val. So we know that this function is working because we already printed the results. What is the error here? is somehow passing a tuple. I think the folding instructions do not contain what we expect. So let's print folding instructions before invoking them. So print folding instructions. Okay, this seems very correct. That's what we want. So part 1, we receive the coordinates, folding instructions. Ah, yes, of course, for the instruction I have to get the first folding instruction. Otherwise because I want only the first one. I'm not iterating over them. Okay. Okay, what is, am I passing the values? Yes. Okay, that actually worked. So, oh, yes, I'm still printing this stuff, so I don't see the result. 17. Yes, 17 is the value, but I want it on my input, so now I copy this thing instead of the sample input, so it was working. 781 is the solution for my problem, and oh, my answer is too high. What? Weird. Why is it too high? On the input example it worked. Am I actually copying the complete code? So let's try to just be sure and copy the whole input again. Maybe I just mixed the stuff here. Okay, I run again. 781. That seems correct. Why is it not working? The input was there. Did it? That's very annoying because there is not very much ways to debug it, if not by just printing. Wait. Yes, this seems correct. So I'm invoking X. Okay, let's try to print. In part 1, I do a visualize chords, and here instead of returning, I calculate it first. So I say that the folded is equal to this thing, and the folded here is equal instead of this thing. So folded equal to this thing, and here just return the length of folded, which I know is wrong. And I also visualize it, so I print a nice set of separators and visualize the folded version. Okay. That's ugly. It's not really visible, is it? No. It's too big, so I cannot really visualize it nicely. No. What do I do? I can only think more about the problem, because we know it on the sample input it worked. So let's copy again. One thing we can check is whether this folding is actually going through the wall, the real actual axis. So instead of visualizing, that is not really useful in this case, we print the folding instructions at position 0. So maybe it's the folding that is not doing what we expect. Is not folding on the correct axis. So folding is on axis X and 655. Is it correct? Yes, it's folding across the correct axis. I'm wondering if there is some error with the way we fold based on the fact that these folding instructions are of the fact that the size is odd or even. That's a good thing to think about. That's very tricky. Yeah, no, this transparent paper, thank you. I don't see any issue there. Fold left, blah blah blah. Oh. Okay, let's try again the sample input. So this was the sample input. Yeah. So I will rename original as real and create my own input, day13.txt, and if I run it again I should get the same result, 17. There is only one thing I have to check, which is that in the real example I start with folding by X, and in the sample problem I start folding by Y. So if there is an error in X and not Y, I will have some issue. So X, Y, this seems correct. I don't see an error here. Weird. Ah, I see. Here is the error. I'm so stupid. I was checking the tuple. So folding instruction 0 is the tuple containing X and the coordinate. So if I compare it with X, will always be false. So it's always folding by X. That's so annoying. So I can, sorry, I wasted some time. So again, I rename this thing, and now it will work. I really think so. Oh, that's annoying. You see, that's why you need type checking. 781 is still the same result. That's annoying. Wait, is folding by X? Let's see. Let's do the powerful print-based debugging. And it's uppercase because it's very important. Okay, so it's not folding by X. Why? Because it's 0, not 1. Ah, it's so stupid. Okay, now it's working. 661 was the solution. I'm sorry. Okay. 661 was the solution, and you saw how real debugging in the real world works. See you later. Bye.